بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 1.3. Suppose the graph of f is given. Write equations. So we need to write equations for the graphs that are obtained from the graph of f as follows. Shift 3 units upwards. So the graph of f y f of x, y equals f of x. This is the function f. If we shift the graph of f 3 units upward, then we need to graph y equals f of x plus 3. 3 units downwards, the equation would be f of x minus 3. 3 units to the right, the equation would be f of x minus 3 inside f. So the change here is in x. 3 units to the left, we will have f of x plus 3. Reflect about the x-axis. When we reflect the graph of f about the x-axis, we multiply y by negative. About the y-axis, we multiply x by a negative sign. Stretch vertically by a factor of 3. When we stretch vertically, we multiply f of x by 3. Shrink vertically by a factor of 3, we multiply f of x but by 1 over 3. This is also stretching vertically. The graph of f is given. Draw the graphs of the following functions, f of x minus 3. Minus 3 means we have to take the graph, this graph, 3 units down. So let us take the graph 3 units down. Here, this point, we will take it down 3 units. This point, we will take it down 3 units. This point, we will take it down 3 units. So we can now graph this part. So we have taken this part 3 units down. Then this point, 1, 2, 3, take it down 3 units. And now connect. So we have taken also this part or this line segment 3 units down. And this one, 1, 2, 3 here. So draw the line segment. So now we graphed y equals f of x minus 3. F of x plus 1, we need to take the graph 1 unit to the left. So if we take it 1 unit to the left, this point would be here. This point would be here. And this point would be here. And now we can connect to graph this line segment. And now this point, we will take it here. So now if we connect these 2 points, we will have the same line segment shifted 1 unit to the left. Okay, shifted 1 unit to the left. And this point, take it 1 unit to the left and connect. So also this line segment shifted 1 unit to the left. So this is the graph of y equals f of x plus 1. Half f of x, this is a vertical stretching, which means we multiply each y by half. So here y is 2, multiply by half, it would be 1. Here y is 1, multiply by half, it would be half. Here y is 0, multiply by half, it would be 0. And if you connect these 3 units, then this, what happened to this line segment when we vertically shrink it, because this is shrinking, not stretching, sorry. Now, this point, 1, 2, 3, so y here is 3, multiplied by half, it would be 3 over 2. And now, this is the shrinking vertically of this line segment. And now this point 2, shrink it to 1 because half multiplied by half. So this would be the graph. So this is the graph of y equals half times f of x. Negative f of x, we are multiplying y by negative, so there will be a reflection about the x-axis. So here, this point 2, it would be negative 2. The coordinate, the y-axis, y would be negative 2. So we multiply y by a negative 1, actually. So here, y is 1, it would be -1. And y is 0, it would be 0. And we connect these 2 points, these 3 points. So this is what happens to this line when you reflect about the x-axis. Now this line at 3, so I need it at 3 here, -3. Y would be -3. And now I connect these points, and this is the reflection of this line. This point is 2, y is 2. It would be -2, and this would be the reflection of the graph about the x-axis. Another type of questions, graph the functions by hand, not by plotting points, which means you use the transformations, starting with the graph of one of the standard functions that we studied in section 1.2, then applying the appropriate transformation. So what is the standard function here? It is y equals x cubed. If you go back to section 1.2, you will find that this is the graph of y equals 2x cubed. Okay, this is the graph of this function. Domain or real numbers and range or real numbers. Now, how to obtain the graph of this function? Well, there is one unit, this is 1 unit up, and there is a reflection about the x-axis, this minus sign. There is an order of transformations. We start by horizontal shifting, then stretching or shrinking, then reflection, and then vertical shifting. What we have here in this question, vertical shifting by 1 unit up and reflection about the x-axis. So we start by the reflection to graph y equals -x to the power 3. So to graph y equals -x to the power 3, we reflect this graph about the x-axis. So this part would come here, and this part would be up, and the graph would be like this. So this is the graph of -x cubed. And now this 1 unit will take this graph 1 unit up, and we will be able to graph 1 minus x cubed or -x cubed plus 1. So when you take 0, 0, 1 unit up, then the graph would be like this. So this is the graph of 1 minus x cubed. Here we have 3 kinds of transformations. This is 1 unit right, and this one 3 units up, and this one reflection about x-axis, So we start by horizontal shifting, HSRV. So we start by horizontal shifting. First, let us start by graphing x squared. This is the original function. So the graph of y equals x squared, we know that it's just a parabola that opens up upwards. All right. Now, horizontal shifting, 1 unit to the right. So I need to graph x minus 1 to the power 2. This means that this graph would be taken 1 unit to the right. So this would be the graph of the parabola. Then I do the reflection. So I graph -x minus 1 square. This is a reflection about the x-axis. So the graph here, and it goes down. And then finally, I take the graph 3 units up to sketch the graph of this function. So if you take this graph 3 units up, this what would happen. You will have, the point was here. So 1, 2, 3. So you take it 1 unit up, and this would be the graph of the parabola. Here find the functions f circle g, g circle f, and so on. So let us start by A, find f circle g of x. By definition, this is f of g of x, and we start by writing the value of g of x, and now we find f of x plus 1. To find f of x plus 1, you replace x by x plus 1. So it is 1 over square root of x plus 1. This is f of x. This is f circle g. Also, he needs their domains. So let us find the domain of f. Well, this is, we have a square root function, so x has to be greater than or equal to 0, but it is in the denominator, so it cannot be equal to 0. So actually, x has to be greater than 0, so the domain of f would be from 0 to infinity open. That's the domain of f. While g has no roots, no denominator, so the domain is from negative infinity to infinity. Now the intersection between f and g, we don't need the intersection here. We need the domain of f circle g. If you remember the domain of f circle g, we wrote a formula for it. We said that it's the domain of g intersection the domain of the result. So this is domain of g, or real numbers, domain of the result. So it would be, in this case, the domain of the result, because g has everything, or real numbers. So what is the domain of the result? X plus 1 has to be greater than or equal to 0, but it is in the denominator, so it has to be greater than 0. So x is greater than negative 1. So the domain of f circle g would be from negative 1 to infinity. Let us find g circle f of x. All right. By definition, it is g of f of x. And we start by writing the definition of f inside. We start from inside to outside. So what is the definition of f of x? It is 1 over square root of x. Now, how to find g of this? We need the definition of g and replace x by 1 over square root of x. So it would be 1 over square root of x plus 1. That's the result, okay, of G circle F. Now to find the domain of G circle F, it is the domain of F intersection the domain of the results. Okay, the domain of F is from 0 to infinity, and the domain of the result the same, because x is in the denominator and it's inside the square root, so it has to be greater than 0. So the domain here is from 0 to infinity, because the domain of the result is equal to the domain of f, so their intersection would be the same domain from 0 to infinity. Part C, find f circle f and its domain, f circle f of x. Similarly, it would be f of x, and we write f of x by definition is 1 over square root of x. Now, how do we find f of something? We need the definition of f. We replace x by what is here. So it's 1 over square root of 1 over square root of x. Okay. If we need to simplify this, I can say that it is 1 divided by square root of square. Let me write this as follows. Square root of 1 over square root of x is square root of 1, which is 1 over square root of x, and that's the fourth root of x. So it's actually 1 times the fourth root of x over 1, which is the fourth root of x. Now this is f circle f. Now what is the domain of f circle f? It would be the domain of f intersection the domain of the result. Well, the result, what is the domain of the result? The domain of the result is from 0 to infinity. Okay, closed from 0 because it is in the numerator. It is in the numerator. Okay, so fourth root of x. There is no problem. Fourth root of x. Now, what about the domain of f? The domain of f is 0 to infinity, open. So their intersection would be from 0 to infinity, open, because we will not be able to find f circle f of 0, because f of 0 is not defined. Okay, although the result we can replace in the result, we can replace x by 0, but the domain of f circle f would be from 0 to infinity open because f of 0 is not defined. That's why we have to find the domain of f and put it there with the domain of the result. Okay, part D, finally G circle G, well, G circle G of x would be G of x, and G of x is x plus 1. So we need to find G of x plus 1. We go back to G and replace x by x plus 1. So it would be x plus 1, and we have 1 here. So it would be finally x plus 2. Now, domain, the result is negative infinity to infinity, and domain G is negative infinity to infinity. So domain G circle G is from negative infinity to infinity. Another question. First, let us find f circle G of x. It would be f of g of x is 2x minus 1. Now, how to find this? I go to f, replace x by 2x minus 1. So I have 2x minus 1 over, I have another x here, so I also replace it by 2x minus 1 plus 1. So the answer is 2x minus 1 over 2x. Now the domain, let us find the domain of f here. All real numbers except minus 1, because minus 1 will make the denominator 0, while the domain of G just all real numbers because we don't have roots or denominators, square roots or denominators. Okay, the domain of F circle G would be the domain of G intersection the domain of the result. Okay, domain of G all real numbers. Domain of the results would be all real numbers except 0 because it will make the denominator 0. So the intersection will be all real numbers except 0, and the domain of F circle G would be in this case equal to the domain of the result. Part B, because the domain of G is all real numbers, uh, let us find G circle F of x. It is g of f of x, and f of x is x over x plus 1. So how to find g of something? We multiply x by 2. So x here is replaced by x over x plus 1 minus 1. So it's 2x over x plus 1 minus 1. Now the domain of the result, all real numbers except minus 1. The domain of f is also all real numbers except minus 1. So the domain of G circle F would be all real numbers except negative 1, because the domain of F and the domain of the result in this case is the same. Okay, C, we need to find F circle F of X. By definition, it is F of. What is F of X? It is X over X plus 1. And how to find f of something? We replace x by all of this. So we will write it x over x plus 1 over, we have another x, we also replace it by x over x plus 1 plus 1. Okay. Now, in fact, to simplify this, we have different ways to do. So I will use this. I will multiply by x plus 1 over x plus 1. If I multiply by x plus 1 over x plus 1, I will get the following. This will be multiplied by this, so they will cancel, and I will have x. And here x plus 1 times this, I will have x. And x plus 1 times 1, I will have x plus 1. So the final answer would be x over 2x plus 1. Okay. Now, domain of f circle f is equal to domain of f intersection the domain of the result. Well, domain of f, all real numbers except negative 1. Domain of the result, okay, this is the result. What is the domain of the result? Okay, all real numbers except negative half, because it will make the denominator 0. So what would be the domain of F circle F? It would be all real numbers except the negative half and the negative 1, because negative 1 will make F0 and negative half will make F circle F0. So this is the domain of F circle F, the intersection between the two, all real numbers except negative half and negative 1. Now G, the last part, G circle G of X. This is G of X, and this is G of, what is G of X? It is 2x minus 1. So it would be 2 times 2x minus 1, because in G we replace x by x minus by 2x minus 1 minus 1. So it would be 4x minus 2 minus 1 minus 3. Now the domain of the result, all real numbers, domain of G, all real numbers. So the domain of G circle G here would be also all real numbers. The last question is find F circle G circle H. So F, it would be F of G of H of X. The first step after this is to plug in H of X. So what is H of X? It is square root of X. Good. And now to try to find G of circle X. Well, to find G of circle X, I need to look to the definition of G of X. And I replace X by the square root. So it is 2 to the power square root of X. And now to find F of this, I go to F and replace X by this. So I will have absolute value of 2 to the power square root of X minus 4. That's the end of these exercises. Thank you very much. Study hard and have a nice time.